Bye. So, hi everyone. Thank you very much for being here. Today we'll discuss the main architecture, the basic architecture for authentication and authorization in Spring Security. Don't hesitate to ask questions. I have the chat here. You can use your microphone as well. Just don't hesitate to ask any question. I will try to explain it in the most precise way I can. We'll start with a bit of theory, and then I will show you some code as well in a very small project so that I can make sure you get everything you need to know from the basics of Spring Security. For those of you who don't know me already, I'm Laurențiu. I'm working as a software developer, and I'm also an author. Actually, my first book that is the most known is Spring Security in Action. I have it here. Hopefully I will tell you a lot of interesting things, and I do have all the knowledge that that I need to teach you everything from this particular subject. So let's start a bit with the architecture in terms of how it works in Spring Security. I would like first to tell you that before starting to discuss about the authentication and authorization architecture, first of all, you should think about what your application does in general. So is it a web application or is it something else? Because depending on that, you will have different or let's say that the basic architecture will change a bit according to how this what your application actually does. So I will mostly refer to web apps because in most cases that's what we deal with in real world scenarios. But I will mention at some point what is different also from what concerns a non-web application that you would secure with Spring Security. So you know probably already that Spring Security is that module from the Spring ecosystem that allows you to implement easily authentication and authorization. Some weeks ago, I had on the same group a presentation where I discussed different ways to configure authentication, and I demonstrated also a couple of them at least. Today, I will go a bit more general, and I will discuss about the architecture behind the scenes, the skeleton that supports the implementations with Spring Security. So again, let's focus more on web apps because most likely in real world you will have web applications that you implement with Spring and Spring Security. And I will try to I will try on the fly to also provide you with the differences from web applications. When we have an application that it's non-web, what happens? So when you have a web application, I think the most important thing you need to remember is that we discuss about, of course, HTTP requests and response. So you have a client, and that client sends an HTTP request, and of course, at some point, in case everything went well, it gets back an HTTP response. So just consider that these two arrows, and I hope you can see my screen. Because I'm drawing here a diagram, and I prefer to draw it together with you rather than prepare it up front in a presentation. I found out with time that people find this more easier to understand. So what happens is that, of course, a client somehow sends an HTTP request, and what happens with the request is that it will be intercepted by the application, but before it gets intercepted by the application, the app might apply some HTTP filters. So the filters in terms of the Java applications web terminology are small pieces of capabilities that intercept the request and can apply different changes or can execute code, business logic, depending on might use the data on the request as well, but not necessarily. But the idea is that before the request reaches the application. So let's say that this last rectangle here that I will draw in a green is the application. This is basically behind the scenes something that we call a servlet, and you might have heard about what a servlet is, but that's not necessarily the case. But just consider this is the application. So the servlet is the end of the HTTP request. When it reaches the servlet, it basically reaches the application. But before the servlet, we have an entire, we call it a chain of filters. So you might have as many filters as you would like here. And these filters, they execute on a given order. So I will just name them F1, F2, F3, F4. You might have as many as you'd like here. So it's not necessary to have only 4 of them. And whenever you define a filter, you usually give it an order as well. Now, we won't go into such a deep configuration where we will have to implement our own filters. But the reason I'm drawing you this first is because in a web app, that's what Spring Security uses behind the scenes. So what does Spring Security do is authentication, authorization, and also applying different mechanisms that help in protecting your application. For example, the CSRF capabilities, which is the mechanism that protects your application against CSRF attacks, is one filter at some point that uses behind the scenes other classes. The authentication itself is one filter. So at some point you have the authentication filter that will somehow drive to the logic behind the authentication. The authorization as well. So this A here says the authentication, and this one is the authorization, and so on and so forth. So each filter is an entry point to an entire engine that Spring Security supports in order to solve a given problem. For example, Spring Security has a specific filter as a starting point to solve the CSRF protection problem, to implement that mechanism for the CSRF protection. The same, it has one filter that is the starting point for authentication. It has one filter that is the starting point for authorization. And once the request passes all these filters, it gets into the application, and then the app can get it. If one of the filters says that shouldn't be the case, for example, the authentication filter finds out that the needed credentials are not sent through the request, or the request doesn't fulfill all the important rules, whatever configurations have been set up, then that filter won't let the request go through, will reject the request and potentially send back a response setting on it a status like 401 unauthorized or 403 forbidden, depending on what happened. So this is again particularly the case of a web application. You send the request, it goes through multiple filters. Each filter has its own logic implementation. The filter is the entry point to an entire mechanism that solves something. And then if everything went well, it goes into the app. If not, then the HTTP response comes back with a status which is most likely not 2xx, which is not an OK status. Usually, if it's something related to security, is either a 401 unauthorized or a 403 forbidden. Cool. So that's basically how it starts. Now, if we take only the authentication, that's basically the most important one that you will configure always, is when we have this filter here. Maybe it's better if I copy it instead of moving it. This is how it looks like, the entire authentication mechanism behind the scenes. So you have the filter, and then from the filter, when the filter intercepts the request, the filter will call a component that's called Authorization Manager. I will call it AM here. This is, authentication manager. This is the authentication manager. Is the responsible component with finding out how to authenticate a given request. So the filter itself, each of these filters, again, I will say it once more, is just an entry point. So it's not, it doesn't contain itself all the capability implemented. It's just the entry point. And the authentication filter, basically, in order to be able to implement the authentication, it directs it delegates the functionality to the authentication manager. And then the authentication manager, furthermore, will find out how to authenticate a given request based on an authentication provider. And here is one important thing to remember, that we might have multiple authentication providers. Why can we have multiple authentication providers? Because, of course, you might have multiple ways in which you authenticate the requests. So nobody says that your application has to only deal with only one kind of request. So maybe you want to have to authenticate your app using basic HTTP basic, but you also want to have some kind of a key, and you also want to have a form login. If you remember, even last time, if you were there when we met last time, you might remember that we've implemented multiple authentications. And again, you might remember that at some point I told you that if you use a Spring Boot project that pre-configures security, when you put the Spring security dependency in your POM XML file, by default, you have both HTTP basic and form login configured. Now, basically, this is the main important stuff. There are two other components that sometimes appear in this architecture, and they are called the user detail service and the password encoder. These two are not mandatory, because not always, we don't always authenticate based on a user and a password. But if we do so, if we have a user and a password, then you need a user detail service and the password encoder, which are the two components basically dealing with finding the details of the user as well as matching the password, saying, helping the Spring Security understand if a password is valid or not. So these two components, they are called directly from here, but again, only if we talk about a situation where our application uses credentials like username and passwords to log in. So this is how it works. So if our request went through multiple filters and finally arrived here at the authentication filter, then the authentication filter will call the authentication manager. The authentication manager will find an authorization provider for that specific request. And in case the authentication provider needs a username and the password validation, it will use a user detail service and the password encoder for that. Of course, any situation where something goes wrong will become a failed authentication. For example, if the authentication manager cannot figure out an authentication provider that can help in that specific case, then this will become an authentication error, and then the HTTP response will go back with the status that says unauthenticated. If the user provided, say it's an authentication provider that requires a username and the password, and the username is not a valid one, then again, failed authentication. If the password is not valid, then again, failed authentication. So this architecture with these components, particularly these components, help Spring Security in authenticating a given request. Now, once the authentication happens, what Spring Security does is to create a security context, and the security context is actually the place, the container where the details, the needed details about the authentication, the authenticated user, if it's a user, the authenticated requests are stored. So the final goal, so maybe I put it like this, the final goal is that when it returns, so say it returns at some point to the manager, so at the very end, if and only if the authentication is successful, then the authentication filter will put in the security context an instance of the type authentication. And this instance contains all the information needed further by the application for the authorization. So I will put this a little bit below, and I will copy this here so that I can represent the link between authentication and authorization. So remember, the final step for authentication is to add the details in the security context. And the reason it does that is to give the authorization the chance to use them, because based on these details, you might then implement different authorization rules. So for example, say you implement some role-based authorization. When the user is found, it doesn't only validate that the username and the password are right, it will also get all the needed details, including, for example, roles that the users might have. And then based on the roles, which are then stored in the security context, the next filter, which is the next mechanism that you can configure as well, will know if a given request should or not be accepted. So for example, maybe this is a request that can only be executed if that given user has a role admin, whatever that means for the application. But maybe the user successfully authenticated, only that it doesn't have the role admin. So in that case, of course, the authentication will be successful, and the authentication details will be stored in the security context. But the authorization will fail because the authorization will read the fact that the user doesn't have the needed role, and will send back a 403 forbidden on the HTTP response, most likely saying we don't accept this request because the role, the needed role does not belong to the user, and so on and so forth. So basically, this is the backbone architecture that helps a web application, that helps Spring Security protect a web application. And well, this is the most difficult in case of the web applications. Otherwise, if it's only a normal application, then you don't have a servlet anymore. You will have an app, and you don't have filters anymore. And in that case, you will only have an aspect taking care of the authentication and the authorization. So instead of having filters that will help you apply the authorization rules, you will use Spring aspects for that. So that's the difference. But again, as in most cases, you will deal with web applications. I think understanding the architecture of a web app is rather more important than understanding a non-web application and the way Spring Security works for that. Behind the scenes, eventually, anyway, you will use the same stuff. Now, of course, let's go a bit into some code and put these components into a small demo example. So I will just create here an app, Spring. How do we call that? Spring security, basic architecture, whatever. And again, let's take a web application and we add the web dependency and the Spring security dependency to it. And that should be enough for our application now. I will create the project and wait a bit for my IntelliJ to index all the needed classes and dependencies. Okay, let's wait a bit for it to finish the indexing. And now, of course, we'll go into, I would like first to add a controller. Just because we need something to be able to prove our configurations. So let's say we have a controller. We configure it as a very simple REST controller. And let's have an endpoint. And you already know that if I will start this, which will definitely first start on port 8080, since I didn't configure any other port, this is the default for any Spring Boot web application. Now I can call the demo endpoint, and by default, as again, you might have already the information, Spring Boot configures Spring Security with a username, a set of credentials, username and password that are generated whenever the application starts. And this is kind of a hello world for Spring Boot. So my Postman is very slow. My computer is very slow in general for some reason today. Probably is because of the heat. It's very, very warm in here. But let's give it the time and be a bit patient. Okay, so excellent. Can have a new tab here. And then we can see that Spring Boot configures Spring Security with the generated credentials. And you know that if I didn't make any change, I will have to use them. So that means in the authorization here, I need to use basic authentication, and the username is user and the password, the one I copied from the console. And of course, I get the right response back because I did authenticate correctly. Okay. Now, of course, that's not the whole point. That was just to show you that first of all, it's working with the default configurations, but the plan is to configure it ourselves. So let's say we want to implement, first of all, our own management for users. That means I will continue to use HTTP Basic, and as you can see, HTTP Basic is actually indeed an authentication way that uses username and passwords. So that means that HTTP Basic, like any other authentication implementation using usernames and passwords, itself will use a user details service and the password encoder. So this is exactly my case here, where I will start by continuing to use HTTP Basic, But instead of having a generated username and password, as you can see in my case here, I would like to have my own users and passwords. So what do I do in that case? So of course I can configure that. Let's say project configuration. And then the only thing I need to do is make sure that I provide a custom user detail service. And then you can implement it yourself, because user detail service is basically just a component that has to load the details of the user by the username, which is considered unique. So you can see that we will always use the interface, the contract, when we implement such things. This is the contract that Spring Security understands as the component that can retrieve details about the user. You will either implement it yourself, or you will use an implementation that is provided by Spring Security. For example, Spring Security already provides a bunch of user detail service implementations. In examples, you will very often see the in-memory user details manager, which actually allows you to just put some users and use them as they are. This is only for examples and tutorials. You can use the JDBC user details manager, which allows you to customize your user details management by taking them from a database directly using JDBC, and so on and so forth. So yeah, in my case, for example, that's why if I'm going to use the in-memory user details manager here, then I will just return it and I will add a user. And say I want to use the user Bob with some password 12345. In a real world example, never use plain passwords, of course, they will always need to be hashed. You need to have at least one authority and then build it. And because I'm using basically the password in plain text, I will have to provide a no password encoder. And again, in a real world scenario, you would use a password encoder that hashes the password, but the idea is the same. So just adding it as a bean in the Spring context. Now you provide the user details in the password encoder. So going back on our diagram, what I did is actually I've customized these two components. So I can customize only these two components and continue to use an authentication provider the way it was defined by Spring Security. That means that, of course, now if I'm running the application, I will definitely see nothing special than just the fact that I have the ability to log in, and instead of having a generated password that was the way you have seen it earlier. Now you don't see it at all, of course, because we do use a custom user detail service. I won't be able to use these credentials anymore. This would be a 401 authorized. I will definitely need to use precisely some credentials that are considered, that are understood by my custom user detail service and password encoder. So Bob and 12345 in this case, as you can see. And that happens only if you use a logic that uses credentials such as username and password. But you might face a situation where you have to implement a custom authentication logic. So what do you do in that case if what you implement is custom? Well, you will basically have to implement an authentication provider, which is the component in Spring Security where you implement the authentication logic. So if you want to do that, then you definitely need to implement your own authentication provider exactly as you see it. So let's see, how would we actually do that? Well, it's not that complex in general. So it's just implementing the authentication provider interface and defining your logic. Say here, packet security, in which I will define my, let's call it custom authentication provider. And for Spring Security to understand it, it simply needs to implement the authentication provider interface. And the authentication provider interface has only a couple of methods you need to override, which are the authenticate method and the supports method. So basically what happens here is that the supports method tells the authentication manager here that the specific authentication provider is defined for a specific authentication type, while the authenticate is basically the authentication implementation. So this is the authentication logic. This is the authentication logic. This is where you implement the decisions based on which you authenticate or not a given request. This only tells the authentication manager which kinds of requests deal with this authentication provider implementation. So now if I want to create my custom logic, I will basically define a filter. Well, I do actually have a filter in this case, but well, it really depends how much would you like to go with the implementation, because I can simply just, if I want, just use this custom authentication provider the way it is and use the HTTP basic filter, or I can implement even the filter myself. Let me show you because it's easier. So in order to do that, what I will do is I will extend the class web security configurer data, and this class has two methods. It has multiple methods. Two of them we need to override. One of them is the configure of HTTP. This method helps me define the HTTP authentication. So I'll just say I want HTTP basic. This is the DSL method to configure the kind of authentication I want to use, which in my case is HTTP basic. And of course, the authorization, which is basically the configuration for this filter here. So the second line I wrote in the method configures this filter, telling it which requests are allowed to go through. In my case, the way I wrote it is just any request that has been properly authenticated. So any request for which the filter will find something in the security context. It doesn't need to have a specific role. It doesn't need to have a specific authority. It just needs to have here an authentication, which means that it has authenticated. So that's the second line here. And the first line telling it, it's just telling it, I want to use the HTTP basic mechanism, which starts with the HTTP basic filter, which I can override as well if I want to customize completely my authentication. So in my case, if I first of all wrote that, secondly, I need to override the method that allows me change the or add a new authentication provider, actually, because you might have more. So where was that configure method? Here it is. And then what I will say here is just authentication provider. And then here you need to provide us as a parameter an authentication provider. So what I will do, I will just make sure this is a component in my Spring app, so that now I'm able to inject it here, say private authentication provider P, and I auto wire it, and then I configure it here. Okay, so I'm actually curious because I left it, now it's completely unauthenticated. I will just add some endpoints here to see if I'm getting through it when I do a debug, so that we can see what happens and the order in which the events are triggered. Okay, my app started, and now I'm going to trigger again the demo. And what you will see is that, first of all, what did I tell you is that this supports method tells the authentication manager which kinds of requests to deal with. This is, you can see that this method has been called first, and that's of course fine, because and it's expected, because the authentication manager needs first to call the supports method to find out if it makes sense to go into the authentication into the authenticate method. So first of all, what happens is, like, the authentication manager asks the authentication provider, are you able to handle this request? And that's the supports method. The authentication provider will tell the authentication manager false or true. Yes, I am able to do that, or no, I'm not. If the authentication provider returns false, then the authentication manager knows that the authentication provider cannot handle that request and will try to find another authentication provider. If it finds it, then we'll call further the authenticate method. If no authentication providers are found, then the request will go back and will be failed authentication, because we didn't find any way in which we can authenticate the request. So you see, in my case, I just returned false. This is my only authentication provider. So just the authentication manager didn't find any authentication provider to handle the request. Let's see what happens if we return true here. So if we return true here, then we should see that, again, the authentication manager calls the supports method, but because it's true, that tells the authentication manager our authentication provider can handle this request. So the next thing will happen is that it will call the authenticate method. So if I'm calling it now, it goes here again, but now we return true. So if I continue the execution, it goes into the authenticate method. And now the authenticate method can do three things. One of them is return null. This means, again, I cannot handle the request. So this is a quite strange, and a lot of people get confused. Null, returning null from the authenticate method doesn't mean the request failed. It just tells the manager, do find another authentication provider because I cannot handle the request. Now you will ask, how and why would you even have then the supports method if you can do that directly from the authenticate? Well, the logic behind the scenes is that theoretically the supports method only decides that based on the class type. So of course, in a real world example, I would not just return true here. I would have to test on the class, on the authentication class, and based on the authentication class, I will decide if I can or not authenticate the request. When I'm getting in here, I have the object itself, so I can decide the same thing, but based on values inside the authentication, which is not that often in real world examples. So you will not often find this case, but the framework offers you this possibility. So in case you do have this situation where you have to implement the decision based on values inside the authentication object, then you can do that by returning null, and that will mean for the authentication manager that it has to look further and find another authentication provider for that case. So that's my case here. It can return authenticated authentication instance. That's an authentication instance for which the is authenticated returns true. And that means the authentication succeeded, and the result of that will be that the object will be placed in the security context. Or, of course, it can return an unauthenticated authentication object, and that means that the authentication failed. So now I did return null, so it will fail in the end if I continue, because being, again, this is the only authentication provider we have. What you can do here is decide if and else. For example, let me implement your very short logic. If authentication get credentials or principal, now it really depends on how the filter is implemented. So let's try with get principal, but again, this comes from the object. I will say if it equals to John, return, and then I need to return here an authenticated authentication. So this is a new so what kind of authentication can I use in a complex project? You would have, of course, this is an interface, so you would have to create, you would probably create your own class. But in my case here, I only have a few minutes left, so I don't want to spend all your time with implementing interfaces, because that's definitely probably something you know already. So let us use this username password authentication class, which is basically nothing else than just an implementation of the authentication interface that I can use now. I can just say new, and then I have to make sure that I use a constructor that makes this authenticated, and say this is the first of all, it's the principal, and then so principal credentials and the collection of authorities will automatically set it to true. So principal credentials, remember never to store the credentials for an authenticated, and then list of nothing will do it for me. So that will basically create just an object for which the authenticated is true. So that is equivalent to making it authenticated, and otherwise we return false. So what does, oh no, sorry, I mean the authentication. Otherwise I will just return, I mean the authentication itself would do it. Because it's unauthenticated. So here it comes unauthenticated, and then you decide to authenticate it or not, or you can simply return it. So that basically means, in my case, particularly this implementation of authentication provider, this very, very dummy implementation of an authentication provider, you need to be John to access the endpoint. So what I expect now when I run the application is that when I send a request, if the username I send is John, the request will be accepted. Otherwise, it won't be accepted. So Bob should not be accepted, but it is. So something didn't go well with my implementation for some reason, because I would have expected it's failed. So let me debug it to make sure. I'm used to not implement very dummy things, so maybe that's the case. So let's send it again. So I'm here, so you can see the authentication object the way it looks like. The principal is Bob, and Bob does not equal to John. So then what we do expect here is the authentication is returned with false. So which is quite interesting, because my implementation actually looks very good. So we return an unauthenticated authentication, and it's still okay. Now it comes back again for some reason, but it's still false. So it's still Bob. And then for some reason, this is still 200. Okay, this is very strange, guys. This actually, either I did something very wrong here and I will have to retest it. Either it's a very big bug in Spring Security that we didn't spot for some reason. But once your authentication provider returns an unauthenticated authentication, it doesn't really make sense. What you can do to avoid that is basically replace, and what I usually do actually is just instead when you don't want to implement you don't want to authenticate the user, you just throw a new authentication exception. Authentication exception is actually it's actually an abstract class, so we will have to find an implementation for it, and that would be what would be the best for us here. Bad credentials exception. That's a good one. I would just say bad credentials exception. So throw new bad credentials exception. So again, from my point of view, it's very strange that returning an unauthenticated authentication cost that 200 OK, and I will check that because it really looks to me like a bug in Spring Security. But again, what you would anyway do in most of the cases is use an exception rather than a false authentication. So maybe that's why it wasn't discovered that case. So now test it again, and it's 401 unauthorized for Bob, and the password anyway doesn't really matter. But if it's John, then it's a 200 OK. So that's how it works. But again, that still doesn't mean it's fine that I returned an unauthenticated authentication and it worked. So that's still not fine. But maybe I will fill in a bug and even solve it afterwards in the Spring Security branch. Yeah, and basically that's mostly it. So now we can go even further than that. So the one step further, if you'd like to go, is remember that here we have actually still used the HTTP basic filter. So if you just again put a breakpoint here, you will see that the request comes from the HTTP basic filter. What you can do further is, of course, even the filter itself, you can customize it. So you might, this was just an example, a very, very small, simple demonstrative example. But in general, when you customize something like that, you customize it because you want to have something special, something that works differently than the filter you already have, than HTTP basic. And in that case, you will of course need more than just the HTTP basic filter, and you will have to create your own filter, which you can. So that's one step further, will be creating your own HTTP filter that uses the authentication manager further for that. So you will see that somewhere here. At the end, the request should sound like HTTP filter. If you I think it's called username and password authentication or something like that. Basic, no, it's just basic. So basic authentication filter. So the basic authentication filter is the filter that is used when you use HTTP basic. And again, this now goes through the authentication manager that further finds our authentication provider. But you can replace the filter as well and use a custom filter that sends something else than username and password credentials. Maybe you want to send, I don't know, the hash of a fingerprint, whatever. I don't have a lot of imagination now, and I'm a bit tired. But the idea is that you can use a custom implementation of a filter, because sometimes from the request you want to take something else than just the username and the password. And depending on what you want to take, you take it, you pack it into an authentication object, you deliver it to the authentication manager. It's same as here, the basic filter. You can see uses the authentication manager. This method is the one that tells the authentication manager to find an authentication provider. The authentication manager finds the authentication provider, like we did here. We implemented our own. You define the supports method telling the authentication provider how to communicate with the authentication manager to tell it which kind of requests are accepted by it. And you implement the authentication logic here in this method, which needs to return either a fully authenticated authentication or, as we have seen here, throw an exception. But again, usually it should have worked simply to have an authentication that hasn't been authenticated. That should have been the case. Yeah, which in the end is stored in the security context, so that the authorization decisions are based on that instance. So in that case, in our case here, this line here, which was the configuration of the authorization server, will just tell we'll just tell Spring Security that as long as you have something in the security context, you can authenticate it. So most likely what's wrong here and what was the bug here in this case when you saw me returning an unauthenticated instance, it should have been that the filter somewhere, if the instance exactly here, so here is the bug, you can see it. So when the authentication result is returned, this should have been one more check here. So here there should have been a conditional. If the authentication is not authenticated, then this row should not have happened. So either you or me, we can fill it and solve the problem in Spring Security, because it's definitely a problem. An unauthenticated instance should not be authenticated. But that's cool. That's why we always have to test our applications continuously, because sometimes even the best frameworks have bugs. Now HTTP filter honestly is not that much used in real world apps, and also again, you can just solve it by potentially just throwing an authentication exception instead of returning your unauthenticated authentication. So it's still not a big deal of a problem, but it's a problem, and we can solve it in the open source and contribute this way to the community. Yeah, I see no questions from your side, guys, and I don't have any more time, but I can say that we've went through everything that we wanted to discuss. So we went through the authentication, how it works with and without username and passwords, with or without a custom authentication provider. We could have, again, further than this, implement a custom filter. But I think you got the idea in the end. And we discussed also about how the authorization configuration then uses the instance from the security context. If you have any question, then now is the time to ask it, and I will try to answer it. So either in the chat, or you can use your microphone to ask me whatever is unclear. Otherwise, as usual, I invite you to also check my YouTube channel, and in case you are interested of a lot of details, I have plenty of videos with a lot of code examples on my channel here. So this is my channel. You can find it by my name, and you can subscribe. And again, lots of videos here, from fundamentals to less easy subjects, all of them with nice code examples you can benefit of. And of course, you can check my site and my blog as well. On the site, you will find articles, but you will also find different other talks where you can find me. So I invite you to join me here as well, and see whenever I have a different other presentation. No question I see from your side. So thank you very much again, everyone. Thank you for joining me and hope to see you for another event. Cheers, everyone. Bye-bye.